So, pop quiz 6, we discussed the first question. Part B. In part B, look, if there's a static question, it means your work should be very systematic. Like you should use proper grammar and structure of the answer should be related. You're not supposed to write anything. Like your sentence should be interlinked with each other. It's not like you shall write one sentence and the second sentence does not relate with the first sentence. It should be a continuation. So two alternative hydrocarbon fuels are hydrogen and ammonia. Hydrogen burns to form a water as the only product, but hydrogen is extremely hard to liquefy, where ammonia is easily liquefied, but it is toxic. Compare and contrast the intermolecular force involved when hydrogen and ammonia liquefy by describing how these forces are formed. So as I mentioned, it's a static question. Your answer must be structured answer. You're not supposed to write anything like the things should be related, the points should be related to each other. First thing, any molecule is there, even it has a dipoles or even it does not have dipole, they will always have the London dispersion forces. So both hydrogen and ammonia, because they have electrons, so whenever electrons are there, there will be London dispersion forces. So they will have the dispersion forces. That is the first point. And how these dispersion forces are formed, because we have to compare and contrast the intermolecular forces involved when we liquefy them. So both have a dispersion force or a London dispersion force. That is a first thing. Then how London dispersion forces are formed? They're formed by a temporary dipoles, induced dipole on the other molecule. So when we have a temporary dipoles and these temporary dipole induce dipoles on the other molecule, this will form a London dispersion, result in a formation of a London dispersion force. And when we compare the size of a London dispersion force, it depends on the number of electrons available. As if you see the number of electron, each hydrogen is 1, so there are 2 electrons available. Nitrogen is 7, each nitrogen, 1 nitrogen 7 and 3 hydrogen will be 3, so total will be 10. So here 10 electrons are available, 2 electron, so which will have a stronger attraction or stronger London dispersion force. So ammonia will have a greater London dispersion force and hydrogen will have a weaker London dispersion force. So it will be difficult to liquefy hydrogen. That's why. So you can mention here the London dispersion force or dispersion forces. So the dispersion force depends on what? It depends on number of electrons. Because hydrogen is having only 2 electrons, where ammonia is having 10 electrons. So hydrogen molecules will have a weak London dispersion force. That's why it will be hard to liquefy hydrogen. Then the second is the bond which is available in ammonia and that is not in hydrogen. Because when hydrogen is bonded with the most electronegative element, such as nitrogen, oxygen, or fluorine, it will have hydrogen bond. So because and the hydrogen bond is actually attraction between the lone pair and the adjacent hydrogen. Like this is one molecule of ammonia. This is another molecule of ammonia. This will be partial negative. This will be partial positive, partial negative and positive. And there will be attraction between the lone pair and the hydrogen of the adjacent molecule, and this is result in a formation of hydrogen bond. So ammonia forms hydrogen bond because ammonia is more. So in case of ammonia, there is hydrogen bond. And why there is a hydrogen bond? Hydrogen bonds are formed by when hydrogen is bonded with a more electronegative element such as oxygen, nitrogen, and fluorine. And it's not like attraction between them is hydrogen bond. The adjacent, the attraction between the lone pair. So the attraction between the lone pair and the partial positive hydrogen, that will result in a formation of hydrogen bond. And because of it, ammonia is having a stronger London dispersion force and ammonia is having a stronger hydrogen bond, so it can easily liquefy. It means you can bring the molecules closer. But in case of a hydrogen, it will be difficult to liquefy the hydrogen. Is it clear? In question 2, the enthalpy level diagram for a reaction is shown. So first thing, you will identify what type of reaction. Reactants have high energy and the product is having a low energy. So means this will be an exothermic reaction. So which change is exothermic? When a sodium solid convert into gas, this will be endothermic because we have to supply energy to convert the solid into a gas. If we have a sodium atom and we want to remove electrons, so we have to provide energy to convert the sodium atom into ion. So this will also be endothermic. Chlorine atoms will form a bond because bond forming is exothermic. Like when two chlorine atoms are there and they combine and they will form a chlorine molecule. Whenever bond forming happen, the bond forming is always exothermic. So this reaction will be exothermic. And here bond breaking is there. As you can see, ammonium nitrate is there. Aqueous ammonium nitrate. When we add water, it will dissociate into ammonium ion and nitrate ion. So means the bonds are breaking. Whenever bonds break, what we call that as endothermic reaction. So bond breaking is endothermic, bond forming is exothermic. So the option C, the bond is forming between the chlorine atoms. That's why it was exothermic. In question 3, excess of a zinc powder is added to 50 grams of 0.5 mole per dm cube copper 2 sulfate solution in a polystyrene cup. The mixture is stirred and the maximum temperature change is determined. The enthalpy change of this reaction is calculated to be minus 185. The data booklet value of this reaction is minus 217. What is a percentage error in this experiment? So how we can work out the percentage error in the experiment? You have the two values. So the maximum value, you can just take the magnitudes because negative sign is just showing that is exothermic. So maximum value minus minimum value divided by the standard, because the data booklet is a standard value. So standard value and then multiplied by 100. So 217 minus 185 divided by 200. Why? Because the data booklet or the standard value is 270 into 100. That will give us the percentage error in this experiment. So what is the percentage error in this experiment when you use this? So it will be 14.7. So C will be the right answer. Remember one thing, if it was uncertain, percentage uncertainty can be positive and negative. Percentage error is always in percentage, it cannot be negative percentage error. It's always like what percentage is variation from the standard value. So you cannot have percentage error in negative or a positive values. Then in the calculation, the specific heat capacity of a liquid is taken as 4.18 rather than the true value, which is 3.85. The use of 4.18 in the calculation, like when we did this experiment, instead of using 4.18, we use 3.8. Instead of using 3.85, we use 4.18. So how this one is calculated, the enthalpy change, because how we calculate the enthalpy change of this reaction. So enthalpy change of this reaction is energy divided by moles, okay? And energy is given by a formula Cm delta T divided by mole. So if we use 4.18 rather than a true value, so if we use a smaller value, what will happen to the answer of the enthalpy change? Our answer for enthalpy change will be lower than the final value. So in the calculation, the specific heat capacity of a liquid is taken to be 4.18 rather than 3.85. So it should be 3.85, but it's taken 4.18. The use of 4.18, what will happen if we use 4.18 in our calculation? A partially responsible for error. No, not about error. It will lower as a lower the error in the final value obtained, has a negligible effect on the final value obtained, it will have a significant effect, so we cannot say. And if you see why A is incorrect, because like the specific heat capacity will increase the final value. Here, when you check the previous part, the enthalpy change of the reaction is calculated to be this one. And the data booklet value is 217. So in the calculation of a specific heat of a liquid is to be taken to be 4 rather than the true value, which is 3.85 joules gram and degree centigrade. The use of 4 point in the calculation, like, because in a data booklet, what will happen when the data booklet value is given, this data booklet value. So this data booklet value is given for considering that the specific heat is 4.18 in comparison to 3.85. So what will happen if we use this value, how the variation will change? Because if we use it, so when you check the values here, see, in the calculation of a specific heat of a liquid is to be taken 4.18 rather than the true value of 3.85. So the use of 4.18 in the calculation, if I use a 4.18 in the calculation, so what will happen? The data booklet value will decrease. If the data booklet value will decrease, so these two values will come closer to each other. Or you can also understand this question, like if we are using in our calculation 4.18, but if the true value rather than 3.85 was there. So if we use 3.85, this value will be higher. So the difference between the two values will decrease. Is it clear, this one? Because the idea, because whenever if you use a true value, like example, here when we calculated Cm delta T, we took 4.18. But if we use a true value, this value, because the specific heat will be higher, so this value will be higher. So as a result, the difference between them will decrease. Or The data booklet value was calculated with the true value, but if you use 4.18, so what will happen? The data booklet value will be smaller, so the difference between them will decrease as well. So both ways you can do this question. In question 4, the enthalpy change of two reactions, the enthalpy change for this reaction when iron 3 oxide reacted with carbon. So we have to make a cycle here. When iron oxide reacted with half oxygen, like 1.5 oxygen, this will result in a formation of iron 2, or because you can make a Hess law cycle, because this is what we need. So iron plus, so what might happen if we add an element like iron plus one whole number 1 by 2, total how many? 3 oxygen we need, so it will be 3 by 2 oxygen plus how many carbon? We need 3 carbon. If they react, like if iron and oxygen react and form iron oxide, how much energy will be there? Minus 824. Because these are formations are given. If carbon and oxygen will react, they will form carbon monoxide. But one molecule of a carbon monoxide is minus 111, but 3 molecules, so it will be 3 times minus 111. And this is what is unknown. When we apply the Hess law, where the 2 arrows are pointing out, that is the start of the cycle, and where 2 arrows are pointing in, that is end of the cycle. So element form reactant and reactant form product is same as element directly form a product. So it will be minus 824 plus x is equals to 3 times minus 111. If we need x, this will go other side, so 3 times, so it will be minus 333 plus 824. Which is 491. So A will be the right. How we get 3O2? Because if you see how many oxygen I need 3 oxygen. We have element, we use a Hess law cycle. Here we have reactant, and here is the product. What link we add? We add a link of element, because the formations are given. Here enthalpy change of formation, like iron react with oxygen, give iron oxide, carbon react with oxygen, give carbon monoxide. So we add element. So we need iron, how many of them? 2. We need oxygen, how many? 3. So how we can have 3? So it should be 3 by 2 or 1.5. And how many carbon we need? We need 3 carbon. So here element form the reactant and reactant form a product is same as element directly form the product. Because it is forming 1 mole here, so it was minus 824. This is forming 3 moles of carbon monoxide, so 3 times minus 111, and this one is X. So element form reactant and reactant form a product is same as element directly form a product. Is it clear, this one? So this was a pop quiz 6, which was related to chemical energetics.